Hi, make a logistic regression model with me on superstore data to determine if they're profitable or not. I'm gonna turn on my laptop. Oh my god. Go into Kaggle and find my dataset. And then I'm going to download it. Then we're gonna open the dataset from the grave of the other datasets. And this is how it looks. We're gonna do a control A, then control T, the table wants headers, and enter, and we have a table. And now we're gonna go into.
All right, so now the next thing we're gonna do is create a sheet called dummy encoding, where we will give binary meaning to the data that we will be using as variables. So what we're gonna do next is create the dummy variables according to ship mode, segment, and category. So I have the things I'm gonna be using saved here. And if you can see that if it's corporate or not, if it's going to home office, if it's furniture, if it's technology, if it's first class, second class, standard class, which class of ship mode, also region, west, east, south. Also, we're looking into heavy discount, bulk quantity, if it's very high revenue. And finally, what we're doing is finding out if it's profitable or not. So the next step is to basically create the dummy encoding. So I have already copied everything. So you can see that there is n minus one of the unique uh, amount of those classifications. I have used this row ID thing, so when we create a table, it is done properly, and then I can remove the row ID thing, and it is gone. And for the formulas, what we're gonna do is we're gonna use the if function. If the customer segment is equal to corporate, for example, then we're going to say 1, or else we're going to say 0, which basically means that if it's corporate, then it's going to show 1. If it's not corporate, it can be probably home office. So we're going to do a similar thing for this one as well. We're going to do this and then equals quotation home office and quotation close, comma 100, done. So basically, I came into a problem, but nothing a control one cannot fix. So those are given as states. So we're gonna go back, get them as general, and it's fixed. For all of these till is south, we're gonna use if functions, go to their category or a column and write their name in under quotation and do the same thing. So let me fast forward this. Next few things are a little tricky. So for the heavy discount part, we're gonna go for if the heavy discount, which is discount, is greater or equal to 20%, then it's a heavy discount, or it's not, because the median of discounts is basically 20%. So we've done that. For the bulk quantity, we're going to do a similar thing if the quantity is greater or equal to 5, which is a very like median of order quantity. Again, we're going to take everything that is over the median as an extreme. So that is a bulk quantity order. And for high revenue, we're going to take $500. For this, we're also going to use if and go back to sales. If sales is greater or equal to 500 and 1 and 0. So that's a high revenue quantity. And if profit is in positive, if it's greater or equal to 0, then it's profitable, or else it's not. So now basically what we're going to do is run the randomizer. So first you go for rand, then it's randomized, then copy everything from here to here, copy it, and then paste with values so it gets logged. Then what we're going to do is use ascending or descending, whatever you want to use, to randomize the data. And I'm going to take 1700 for 1700 and 1700, so 3400 for my training data set, which will have a 50-50 split of is profitable and is not profitable. And for my test data set, what I will do is I will take total 850 with basically 80-20 split of ones and zeros. And why is that? Because the real data shows an 80-20 split of ones and zeros. So now basically what we're going to do is create a training set of data, training sheet and test sheet. Training sheet will have the 3,400 of these, and the test sheet will have 850 with a 80-20 split. So what we need to do, we have moved the 3,400 data points, and now what we need to do is create a column to the left that's going to be called intercept. And what we're going to do is get one for every intercept we have. So get on with it. Yes, I'm going to create a table on top for the model coefficients. So the model coefficients will help us determine which variable is affecting what, how much. I know it sounds vague, but that is literally what it means. For this, we're gonna keep one on every one of them, and also we're gonna do this so we can see the decimal points. And now we'll be adding a few things to here, which is basically linear combination, sigmoid transform, and finally probabilities. So something we need is basically the likelihood, which we will determine in just a bit. So for the linear combination, what we're gonna do is we're gonna sum product our variables with our coefficients. And we have to remember to lock our coefficients, or else it's gonna be all hell is gonna break loose and you're gonna lose your mind. For the sigma transport form, you're gonna use exp for linear combination, and we're gonna divide it by 1 plus exp for linear combination again. And that, I missed the bracket, but that basically gives us the sigma transform. And from probabilities, oh boy, you gotta remember this one. It's hella tough to remember this one, so you just gotta wall with it. So what you have to do is basically go for is profitable, which is what we're trying to find here. Then we're gonna do a ln of the sigma transform. This is to keep the values from going crazy. You will understand it later on. And then we have to sum it up with 1 minus its profit, if it's profitable or not. And then we have to do a ln of 1 minus sigma transform, which is all of the probabilities in the likelihood, and it's gonna come something randomly weird. And then we have to run our solver, and oh boy, you would love this. For solver, we have to go evolutionary by changing variable cells. The cells that you want to change are the coefficients, all right? And then for the restrictions, what we're going to do is coefficients will be will be less than 10 perhaps. 10 will be greater than them, so they're going to be less than 10. And the same thing, the coefficients are going to be greater or equal to minus 10. This keeps a constraint on them. You can do 5 or minus 5 and so on. My computer is going to blast. As you can see that our likelihood is maxed up and our model coefficients are ready to take into test set. Now this is basically our logistic model, and that we're gonna use on our test set. And do the same things, linear combination, sigma transform, and probabilities again. And we're gonna go into probabilities and fill them up with formulas as before. As you can see that we have already gotten the data in these columns from the previous formulas that we used. We just repeated them all over again for the test set. Now we have created an ROC sheet here where we will put the sigma transforms minimum and maximum in two places, which is minimum of sigma transform and done, and basically maximum of sigma transform uh, and done. So now what we're going to do is go on to the next step. We're going to create 3 columns of probability cutoff, false positives, and true positives. For probability cutoff, the first thing is going to be sigma transform's minimum value. Then we're going to go into fill, then go series and columns. Chip value, take 0.01. Stop value, you can take the max or just 1 because it's going to be always around that, and get a probability cutoff table somewhat. So we're in the middle of writing a very, very weird formula, and you have it written down. First, we have to give it a name using the let function. Should be test functions, the whole sigma transform. There we go. And then we have a color. Then we do this. Basically, what you need to do is name it null positive, then go on this transform, then we go for this, and then ampersand, and after that, we go for the probability cutoff. After the probability cutoff, we go for if it is profitable or not, just in this column, and then we cut it off with a comma. And also, I think here we need a 0 somewhere. 0, and then we close it, and I think we have almost probably figured out the formula. It looks colorful, and it's done. For the false negatives, what we're going to do is copy this one and then go here, paste it. But we're going to change up a few things. For example, this is going to be 1, this is going to be 1. All negatives is actually going to be all positives because this is for true positives, right? And the same thing goes here. Positives, model false positives is going to be model true positives. And even here, it's going to be model true positives. And we have it. Now we're going to create the ROC curve. Do is take both of these data sets, drag it down to the bottom, go into insert, and then recommended charts. And yeah, this is our ROC curve. Yes, so that is how we get our ROC curve. All right, so we're done with making the ROC, but we made a little mistake back in test where we had to really not keep it till intercept. What we have to do here is basically select the whole thing from is corporate to high revenue, and then keep this as it is. We're just gonna remove intercept from everywhere and do a plus for the intercept, lock the intercept, and that will give us the similar data, which will fix every other column, so we don't need them, and we don't need the probabilities column here for the test data. All right, so after getting the ROC curve, we need to find out true negatives and false negatives. For this, we will just equals 1 minus false positive and equals 1 minus true positives, and we'll have it. Then we'll determine the area under the curve. For this, we will do basically true positive plus the bottom true positive. Then we're gonna divide it by 2. So what we have to do is basically find out the sum of the area under the curve, which will give us a total, which will give us a total understanding of the whole data set. So this basically means if it's more than 85%, then it's good. So next thing we need to do is determine a cutoff value. I'm going for this one for the cutoff value. And what we will do next is open a new sheet. And so we have named the new sheet as performance logistics. Next thing we will do is bring every answer from the is profitable thing from the test sheet and put it in actual. And then we're going to do a prediction, which is basically equals if anything, any sigma transform amount is greater than equals to the intercept amount, which we need to lock, of course. So let's lock it, and then it should show 1 or 0. So these are basically predictions. So the next step is finding out the confusion metric. So we're going to do count ifs, then we're going to choose the whole thing, and if it is 0, then we're going to choose the whole thing. If it is 0, it's going to be the same. And for this one, we're going to do another count ifs, and you understand the whole thing, so on and so forth for the true negatives, false negatives, and false positives. For this, it'll be 1, and then for this, it'll be 0. And even for these, count ifs equals 0, comma 1, and count ifs 1, comma 1. So more or less. And finally, we'll be measuring the precision recall, F1 accuracy and specificity, all according to these and according to a few formulas. So here I have a list of formula that I will be using for this. These are very basic, plus, minus, and everything, like the division formulas. So first we take this, then we take the bracket, TP plus FP, so TP plus FP, and so on and so forth. So as you can see, that is it. We have our model, we have our ROC, and more or less that is it for our regression modeling. Thank you for being here with me. That's it, the end.